absent, and I don't know who else is absent, but it's just a lesson I don't want to have to teach over and over because it's a lot of stuff. Okay. We are doing sum and difference formulas today. They are here on your identity sheet. Can you please find this section on your identity sheet? I don't want anybody to say in 5 minutes, I have no idea where you're getting these, okay? Did you find it? It's like right across the middle band of the identities, okay? We are going to use these 6 relationships today to do a bunch of different stuff. The first thing we're going to talk about is expanding one that says cosine theta plus pi over 2. So we're going to go to the identities here. Which one looks like the right one we might be using? Okay, cosine A plus B. Everybody okay? It's a cosine, it has a plus, right? So I'm going to rewrite what you're seeing on that sheet. It says cosine A plus B. That's supposed to be a B, sorry. Equals cosine A cosine B minus sine A sine B. What are we going to put instead of an A, though? Our theta is going to replace all those A's, and instead of B, we're going to write pi over 2, because that's what our question was. Everybody good on what we're doing here? So write this out, replacing those with thetas and pi over 2's. So we'll say cosine of what? Theta times cosine of pi over 2 minus sine of theta times sine of pi over 2. Now we're going to flip to the other side of our unit circle. And we're going to substitute in some values because we know exactly what the cosine of pi over 2 is. What is it? It is 0, so we have cosine theta times 0. And back here, the sine at pi over 2 is exactly 1. So if we take the cosine of theta times 0, we get 0. And back here, we have minus the sine of theta times 1, which is just negative sine of theta. And that's what we're looking for here, okay? This mess simplified down to the opposite of the sine of theta. Can anybody describe that for me in terms of graphing? What was the cosine one? What happened to the cosine to make it into a negative sign? Okay, I'm trying to relate this graph to this graph. This is a cosine that has been what? Shifted to the left pi over 2. When you do that, it turns into a negative sign. Okay? All right. Moving on to this one. I'm going to not write out quite as much stuff, and honestly, this one is not going to be as pretty because is the sine and cosine at pi over 6 anything, or at 60, I'm sorry, anything nice? No. So this is not going to be pretty when we're done simplifying it like the last one was, but can you find sine of A plus B on your sheet? What does it say? Okay, sine A, but what are we putting in place of A for this question? 60 degrees. Then it says times cosine of B, only we're going to write times cosine of theta. Then it says plus cosine of A, which is cosine of 60, times sine of B, and our B is theta. All right, like I said, the trades aren't very pretty. When we flip this over, what is the sine at 60 degrees? Okay, times the cosine of theta, plus, what is the sine at 60 degrees? Cosine at 60, thank you. It is 1/2 That doesn't simplify, that's what they're looking for. Yuck, yuck, yuck.
That's it.
Yep. Whoa. Okay, or I could just cross the answer out. All right, are you getting the hang of this? Could you try this one? Anybody get that? 1/2 cosine theta plus square root of 3/2 sine theta? I need to go over it again?
Is this as hard as it gets?
No, unfortunately. Yes, this is easy, and you should all be able to do this. All right, number 4. I think of this as a word problem. Okay, this is kind of a story problem. The story is just very trig related, okay? It says the sine of little angle alpha is at 8/17. And little angle alpha lives between 0 and pi/2. Okay? So where on our coordinate plane is little triangle with an alpha living? What quadrant? Between 0 and pi/2, or 0 and 90 is quadrant 1. So we are going to need to draw, just like you often have to do with word problems, a little triangle, and we're going to label what on this triangle? If it's sine, if this is triangle alpha, this angle here is actually alpha, but the sine is opposite and hypotenuse. Now, we need to find this piece down here. So x squared plus 8 squared equals 17 squared. If we subtract, we get 225. Square root of that is 15. It is an Pythagorean triple we will use several times. All right, but that's only half the story. Who's the other character in our story? Yes, we have beta here. We know that the cosine of beta is 7/25, and beta lives between 0 and pi/2, which is also in quadrant 1. Okay, cosine is adjacent over hypotenuse, so we're looking for this side. Is it 576, guys? When you square root 24? Yes? Okay. Quadrant 1 is nice. Do we have any signs to worry about? No. Okay. Now, the directions to this question say, find the sine of alpha plus beta. I was nice and wrote this out on our screen, but you don't have this written out here. You have to look it up, right? You know what I'm talking about?
Yeah.
Sine alpha plus beta. You're going to flip to that side, and you're going to write, okay, the sine of A. Well, this is our triangle for A or alpha. What is the sine here? 8/17. They told us that right over here, right? And then it says times the cosine of beta. Does everybody know where I'm getting this? Okay, I put in here 8/17. Now I'm on this one. Cosine of beta, got to switch over to this triangle. Cosine was what? 7/25. That they also told us in the directions up here, so we really didn't have to do anything yet. But now we get to the second half and it says cosine A, so we gotta go back to triangle alpha and find the cosine, which is 15/17 times the sine of triangle beta. What's the sine over here? Okay, the only good news is they have a common denominator, okay? 8 times 7 is 56, 17 times 25, 325, 425, 425. Okay, 15 times 24? And 17 times 25 is 425 again. When we add, what happens? Did I add right, guys? Okay. That's almost 1, right? 416 parts out of 425. Okay? We found the sine of A plus B. Where is the sine 1? What? This is, okay, wait a minute. Zach's confused. Okay, I'm just saying this is approximately 1. I'm just trying to tie this together for you. 416 out of 425 is close to 1. That means when I add these two angles together, I get close to 90 because that's where the sine is 1, okay? So I don't know if this was a 63 and a 33, that would be over 90. Well, this is short of 90, yep. Okay? Actually, if we went into the second quadrant, well, the sign would still be positive, so we actually don't know. Okay? But we don't know what this is. It's not 60-30. Because we know, are these 30, 60, 90 triangles, guys, with these numbers on there? No. All right, moving on. This is the answer. Did everybody get that ugly, disgusting answer? Okay? That's what you're looking for, an exact value. All right. This one, we're still trying to find the sum of the sine A plus B, but this time, little angle alpha is living in what quadrant? Between pi and 3 pi over 2 puts us third quadrant, right? Draw your bow tie triangle in that third quadrant. Cosine is adjacent over hypotenuse, so the 17 is my hypotenuse. From angle alpha here, I'd have a 15, which is negative. Okay. If I do Pythagorean theorem, it's one we just did. You remember what it had? When a 17 is on the hypotenuse and a 15 is on a leg, the other one was 8. But negative. We are in quadrant 3, right? Both x and y. We went left and down, so this 8 needs to be negative. Okay. Our story also had an angle beta in it, and angle beta was located in which quadrant? Between pi over 2 and pi is up here in quadrant 2. So with the x-axis, or our little bow tie triangle here, we have beta. And it says the tangent is negative 12/5. Okay, opposite over adjacent. Which one of those has to take the negative? Okay, because we went to the left and up in that quadrant, up is not negative, right? But to the left is negative. All right, and somebody know that triple?
13.
Okay, you can do Pythagorean theorem. Be sure if you do Pythagorean theorem with a -5 that you put it in parentheses, right? Should come out 13. Okay. Now, we're trying to do the sine of A plus B, so we go to this on our identities sheet. We trade out the sine of A for what? Here's triangle alpha. Sine was -8/17 times, it says, the cosine of beta. What are we going to substitute in there? Cosine over here of this part of the story.
You get that over the J.
Plus, going back to A, what was the cosine in this one? Times the sine of B. We're back to this triangle. The sine is opposite over hypotenuse. 12/13. Gunther, can I go back over something? Okay. If I multiply here, I get a positive 40 over, thank you. And I get a plus negative 180 over 221. Did I do that right, guys? So when I add fractions, I add the numerator, keep the denominator, as long as they have like denominators. So I get negative 140 over 221. Okay. Tedious, detail-oriented kind of problems, not exceptionally difficult, just a pain in the neck, right? All right. Can you guys work on this one? Notice the directions changed, okay? So we're doing cosine A minus B on your identities sheet. Okay, but try drawing these. Somebody else want to come up and do it or not? Go ahead, Sean. Read your story carefully about where they're located. Okay, can you label that one alpha so we keep it straight? Yep, you're fine. I know you would have got there. Okay.
Nice one.
Okay, before you go any further, they are both 3, 4, 5, yes? Did you get that far, guys? Okay. Sean probably would catch himself in a second here, but does anybody have something different?
Oh, negative 3.
Okay.
And another negative 3. And a 9.
Yep. In quadrant 3, we need both x and y to be negative. And in quadrant 4, we need the y to be negative. Everybody okay now? All right, start plugging values in. Sean's lucky I put it up at the top there. You guys have to be looking at your identity sheet, right? Anybody else want to cry just a little when they finish this one?
Yeah. I'm already crying before it's over.
This is one of those things in math that you're so glad you put 0.
It's not undefined.
Good job. Good job.
Undefined is between.
All right, so that was, yes, a lot of work to get an answer of 0. And like Sean and Noah said, that's why on math contests, when we get an ugly question, we can't figure out what's going on, a good guess is just put down 0, because sometimes that's what happens. All right, is anybody lost on that one? Okay. Oh, we have one more of these? Okay, somebody else want to try this one? Thanks for volunteering, Cody.
Yeah. No, Cody, you're standing up. Good try. Come on.
All right, guys,
That's a hard pass.
you race me. I'll go slow.
So,
Hey, give me a 5-minute head start, and still go slow maybe after you.
Maybe.
Whoa, I'll mess up and then I'll have to go back and erase. How's that sound? All right, how we doing on our triangles?
Isn't that -7?
It is not -7. It's 5, and it is negative because we're in quadrant 2. Does that mean Carrie forgot the negative? Was that because you forgot the negative, or? I'm going slow. I don't feel, oh, that's because I can't multiply. I'm like, I don't feel like this should be this. Just checking if you were watching. How'd I do? Did some of you beat me and you got it right?
Yeah, I did.
Good job.
But you went slow, so it doesn't matter.
Thank you for mentioning homework, Brennan. This is really important. Can you please pull out your pink sheet, or you're going to want to kill me in a little bit?
Wait.
Pull out your pink sheets. Okay? Page 587, which is the 9.2 assignment. It's like the day 2, right?
Yeah.
Yeah, it is only 8 problems, and I'm going to ask you to change number 38 out for number 39. So cross 38 out and add 39. I'll show you why in a couple minutes here, but it has, when you draw, if you were to do 38, instead of a nice Pythagorean triple with whole numbers, it's got radicals all over in it. So I decided to just change it out for an easy one, okay? All right. Okay, guys. The bottom, we have a lot to do. We have the back of this to get done too. So can you stop chatting, please? Okay. This is just looking a little different, but it's the same kind of question. We're going to discover something nice here. Okay? There's a little trick we're going to figure out. All right. Right here. What quadrant are both A and B in? First quadrant. Okay. Guys, please stop talking. A, or alpha, has a sign of 12/13, which makes this side down here 5. Okay. Beta is also in the first quadrant, and it has a cosine of 24/25. Did anybody figure out what the...
7.
It is 7. Okay. So to try to make this problem go a little faster here, it says the sine of alpha is 12/13, and the cosine of alpha, if we just write it up here, then we won't have to keep looking at the picture. What's the cosine of alpha?
5/13.
Okay. And then for beta, it says the cosine is 24/25, and we're going to put the sine up here. What's the sine of beta? 7/25, right? Is that what you said? Okay. All right. I don't have the formula written out here. Can somebody tell me what, one step at a time, what we need to do for sine of alpha plus beta?
Sine of alpha.
Sine of alpha would be 12/13 if we look up at the top, right? Times cosine of beta was 24/25. Am I doing okay? And then what does it say, minus or plus? Plus sine or cosine of alpha, which is 5/13 times the sine of beta. Where am I getting that stuff that I'm just making up? Off the identity sheet, right? Everybody okay? All right. This is 288 over,
325.
thank you, plus 35 over 325, which is, whoa, I don't know what happened to that denominator right there. Okay, can you work on cosine? Cosine is the one I like because it goes cosine, cosine minus sine, sine, right? So those numbers are 5/13 and 24/25. So what are we getting here? 120 over 325 minus 84 over 325. Did anybody else get that? Did I do one wrong? Is that wrong? 12 times 7?
No, 170 should be 84.
That's what I have.
Oh, yeah.
I don't know.
Okay. 120 minus 84 is 36 over 325. Okay. Now, I'm going to have you put your pencil down.
I have a pen.
Your pen. Okay? Because you don't want to write this down. Because you're going to discover a brilliant concept. Okay? The tan, guys, please. Tan of alpha plus beta is tan alpha plus tan beta all over 1 minus tan times tan. Okay, help me plug those numbers in. What's the tangent of this one right here? 12 over 5 plus the tangent of this one, 7/24. Oh, are we having fun yet? Not even common denominators, right? Down here we have 1 minus those two numbers multiplied together, so 12/5 times 7/24. Okay? Common denominator up here would be 5 times 24 is 120. So we got to multiply this by 24 over 24 and this by 5 over 5. So what's 24 times, that's 288 plus 35. 288 plus 35 is 323 over 120. Okay. Down in the denominator, I have 1 minus 84 over 120. 1 is 120 over 120. What is 120 minus 84? 36 over 120. So I ended up with 323 over 120 being divided by 36 over 120. What happens? We flip the second one over. We end up with 323 divided by 36. Anyone have a reason why it came out like that?
Because it's the top one goes back.
Okay. You're saying this divided by this would have also given us this answer? Why is that?
Sine over cosine.
Because tangent is,
Sine over cosine.
so the sine of alpha plus beta divided by the cosine of alpha plus beta is the tangent of alpha plus beta. So why would we want to use this ugliness, right? Okay. As long as it asks you for both the sine and the cosine, just pull one over the other and do tangent. Why would you use that mess, okay? If it doesn't ask you for both, you can decide, is it worth doing both so that I can find tangent easier, or would I rather just use that ugly tangent formula? It doesn't matter. All right, on to the other side. So make sure you write this answer down, but as far as work on your paper, I would have just said that tangent is sine over cosine, so therefore it's 323 over 325 divided by 36 over 325, which simplifies to 323 over 36. Everybody okay? All right. We used to, in the old days, have to do a ton of these. It says find the exact value of the cosine of 345. Okay? The only thing I have exact values for are on my unit circle. Is 345 on my unit circle? No. I need some numbers, in this case in degrees, that either add or subtract to 345, but I need to use only the numbers on my unit circle. It's 360 minus 15 was suggested. Is 15 on our unit circle? But we need a 345. Did anybody come up with something? 300 plus 45, does that work? Are 345 on our unit circle? Okay, so we need to whoops, not sign. We need to rewrite this. Everybody do this one with us. We're not gonna do these on homework. Okay? I did not assign a bunch of these, no. No. This is 300 degrees plus 45 degrees. All right. Now, the rule we're using is this then, correct? Plus. All right, we're going to spread it out or expand it. So it says cosine of A. Well, our A is 300. We're going to write cosine of 300 times cosine of 45 minus sine of 300 times sine of 45. Okay, all I did is expand this off my identity sheet. Did I lose anybody yet? Okay, flip your identity sheet over and look at your unit circle. What is the sine, or I'm sorry, the cosine at 300? Watch your signs. Cosine at 300 is positive 1/2. Cosine at 45, nobody should even need to look. Square root of 2 over 2. Okay, sine at 300, negative square root of 3 over 2. Now there was a minus here as well, so that's going to become plus positive in a minute. Times sine at 45, square root of 2 over 2. Okay. These two multiply together. 1 times square root of 2 is square root of 2. 2 times 2 in the denominator is 4. Minus a negative, we can make plus positive. Can we multiply those together? Yeah, it's square root of 6 over 4, right? Because we're not canceling anything, we're just multiplying. When we multiply fractions, we have to multiply the denominators. We don't get to just keep the denominator. So the actual answer in exact form for the cosine of 345 is the square root of 2 plus the square root of 6, all divided by 4. Okay,
And if someone's gonna try and simplify that.
hmm?
And if someone's gonna try and simplify that.
Yeah, exactly. Does not simplify. Good question, Noah, or good comment that people will try. All right, number 3. We are not going to finish all of these, but I need you to do a couple more with me, okay? Number 3.
Where's number 2?
What?
Where's number 2?
I just whited it out because we didn't need to do it. These are kind of cut and pasted together. Okay. I need you to expand this disaster for me. Can you guys work on that on your own for a second? Cosine pi over 2 plus x is using this rule.
Oh, okay.
Okay. That was this one. Now I'm going to do this one. Everybody okay with where those came from up here and here?
Alright. It doesn't matter.
Okay. Now, we're going to trade out values. What is the cosine at pi over 2? So that one's going to, this whole thing multiplied times 0, gone. Okay, sine at pi over 2. So this is going to be negative 1 times the sine, or just negative sine. Okay, sine at pi over 2 is 1. So this is 1 times the cosine, or just cosine. Cosine at pi over 2 is 0, so that will disappear. We have equals 0. Does anyone know where that's true? If I move this over here, it's basically saying the cosine of x is equal to the sine of x. If I add the sine over the other side, look at your unit circle. Where are the two places on the entire unit circle? Okay, 45, it says use between 0 and 2 pi, so we're going to call that pi over 4. And why is it at 5 pi over 4? Because they're both negative, right? Negative square root of 2 and negative square root of 2 over 2. Sorry, I didn't say that right. All right, so we were able to solve that messy equation for these two answers by expanding and substituting values in. This is really important. I need you to be awake. Not zoning out here, okay? I had a lot of trouble with this question in the last class, and it's not meant to be trouble. When you see this disaster, you need to look at your sheet and say, where does it say tan plus tan over 1 minus tan times tan? Tan A plus B, okay? All of this is equivalent to a tan A plus B. But what is A in this question?
4 pi over 15.
And B in this question was a pi over 15. Okay? Now, we can add those together. We get tangent of 5 pi over 15, which reduces to a tangent at pi over 3. Now, on a test or quiz, honestly, these kind of questions usually just say simplify. So it might be that when you added them together, it came out, 2 pi over 15, and then you would have been done. But this particular one said evaluate and find the exact value because we can. What is the tangent at pi over 3?
Square root
All right, question 5, I'm gonna skip. These are meant to be quick. Can you look at these, guys? You could do this a couple different ways. I would like you to go backwards. Can you find one that says cosine, cosine, minus sine, sine? Cosine, cosine, minus sine, sine. Okay? Which in this case are 3 pi over 2 and pi. Which this becomes a 2 pi over 2, so when you get a common denominator and add together, Noah is right, you get 5 pi over 2's. Okay, think with me for a second. Here's 0, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2 is right back up here, right? This is equivalent to 5 pi over 2 right up there. So what is the cosine at that spot? All right, this one does not simplify that like that because it has an x in it. All right, do you see one on your sheet that says tan minus tan over 1 plus tan times tan? Tan, is it a plus b or a minus b? Okay, what is our a? 30 degrees, and what is our b? Okay, so this is our simplified answer. There's nothing we can do with that. Okay? These are identities. How much time do we have? Okay, 13 or 14, pick one. 13 or 14, which one would you like to do together? 13, okay. We need to expand this mess. Cosine A plus B becomes cosine of A times cosine of B minus sine of A times sine of B, which is x, sorry. Okay, all of this is equivalent to this mess down here. Then we have plus this, which is the sine of A times the cosine of B plus the cosine of A times the sine of B. And it's supposed to equal 0, but I'm out of room. All right, so I'm going to do some substituting. Cosine at 5 pi over 4. Yep.
Shouldn't that be a minus sine 5 pi over times cosine x minus cosine 5 pi?
This one back here?
Because it's a minus b. For an
Oh, this is wrong up here.
Yeah.
It's supposed to be a minus, so then this is supposed to be a minus?
Yes.
Thank you. I thought I copied the right one onto there, so I was believing it. Okay. Minus, what's the sine at 5 pi over 4? The sine at 5 pi over 4?
Oh, wait, okay,
Positive or negative? Ah. That's supposed to be a 2, guys. Minus the cosine, which was also a negative, square root of 2 over 2. Okay, we have a disaster going on here. One of these and another one of these, right? So we have negative 2 square roots of 2 over 2 cosine of x. This becomes plus positive, and this becomes plus positive. So when we add those together, we also get 2 square roots of 2 over 2 sine of x. And that's supposed to equal 0, and this was plus, sorry. right, this reduces to what?
Square root of 2.
Just a negative square root of 2 cosine of x. This is just a square root of 2 sine of x. If I move that over to the other side, what could I do? If I just divide that off, where are the sine and the cosine the same after all that garbage? Pi over 4 and, now, did it say 0 to 2 pi in the directions?
Yep.
Okay, so these are the two answers they were looking for. Okay. I didn't put one of those on a quiz or test. And there's not one on the homework.
Am I allowed to cry after that?
You're allowed to cry, okay. You only have 8 problems on this for homework, all right? They're not like that.
I think I might cry just for one I'm going to get some food. I helped you.
Okay, the corners are starting to hurt, and I'm afraid that, oh, this is just gonna like, I'll be walking, and it's just gonna.
Uh-oh.
Yeah, it's I'm getting a gym bag.
I always find that funny.
5.
In all my classes, like especially ones like this, everyone
Yeah.
has one.
No, kitty bug.
No.
So